So when we start to set up number 8, it says from the top of the lighthouse, so I drew a lighthouse right here, from the top of the lighthouse, 55 feet above sea level. So sea level is down here, right? So the height of this is going to be 55. It says the angle of depression to a boat is 14.3 degrees. Now what I always do is I draw a straight line and I try to create some kind of triangle, okay? So angle of depression, you're always starting from the top, you do a straight line, and you always swing down to where you hit the hypotenuse of your triangle, or to where you hit a piece of your triangle. So right in here, it's 14.3 degrees, and that's why if they see the boat down here, their eyes are swinging this way, and then they hit the line of sight for the boat. Then there's lots of ways to do this, but then what I like to do is I like to find this inside angle of my triangle. So if I know that this is a right angle, I would do 90 minus the 14.3, and remember our mode needs to be in degrees. So I would get 75.7 degrees. Now then the problem says how far from the foot of the lighthouse, so this is the base of the lighthouse, to the boat. So we're trying to find this distance on the bottom. So you can call it any variable, it's an unknown, but we're trying to solve for x. So remember, for these triangles, you're either dealing with SOHCAHTOA to find angles, you're dealing with 180 minus the interior angles to find a missing angle, you're doing Pythagorean theorem, so you just need to think, what do I need to use in order to find that piece of information? So I'm going to look at SOHCAHTOA. SOHCAHTOA. So I'm going to work with angle 75.7 degrees. So in reference to that angle, x would be the opposite, 55 would be the adjacent. So I want to go with O and A. So O and A, so I'm going to work with tangent. So I'm going to say the tangent of angle 75.7 degrees is equal to the opposite, or x, over my adjacent. Then, if you multiply both sides by 55 to get rid of the denominator, we will have that x is equal to about 215.7, we'll throw our units in there, feet. And again, make sure you're in the right mode. It said degrees in the problem, so we're using degrees, mode degrees. If it doesn't say degrees, make sure your mode's in radians. So for the next problem, we have bearing. So it says that this plane that we're looking at, this plane is leaving an airport, traveling at a certain rate, 375 miles per hour, and it follows the course with a bearing. We're starting to head south, right? So we're going down, and when we swing to the west is to the left, and I'm then going to draw another line. That angle is 47 degrees. What I then do is I continue both those lines and I extend them so that I can create a right triangle. If I then label, I know that this distance down was my south, right? Up and down is north or south. Left and right is east and west, so I know this is west. So there's different ways of doing this problem. If you look at the answer key online, there's one way. If I'm doing it here, there's another way, but you still end up with the same answer, okay? So there's different ways of doing this. So I have this angle. I know this is 47 degrees, and if I want the west, that's the opposite. Oh, and sorry, let me back up a sec. So it says that this is the plane, right? The blue route, it travels south, swings to the west, but this hypotenuse is the plane flying, right? And if it flies at a rate of 370 miles per hour, but it's going for 2 hours, it has flown 750 miles. So I forgot to put that there. So now if I'm working with 47 degrees and I want to find the west side in reference to angle 47 degrees, west is opposite, and I have the length of the hypotenuse. So because I want the opposite, I want the west, and I have the hypotenuse, I'm going to go with sine. So then I get sine of 47 is opposite, which is the west, over the hypotenuse 750. We then multiply both sides by 750, and sine of 47 degrees times 750 means that the west is going to equal 548.5 miles. I just drew a new triangle because it was kind of messy. So now if I'm trying to find the south, there's different ways of doing it. If we just found the west, we could do Pythagorean theorem, but I'm going to pretend that I chose to find south first. Again, different ways of doing this. So if I'm working in reference to angle 47 degrees, 750 is my hypotenuse, south would be my adjacent. So I'm going to go with cos because I want the adjacent and have the hypotenuse. So we'll say the cos of 47 degrees is equal to the adjacent, which is the south, over the hypotenuse 750. And when you multiply both sides by 750, you get the south length is 511.5 miles. So for this next problem, it says that there's a weather balloon, and it says it's directly west of 2 observing stations. So west from the center is to the left. So I know my observing stations need to be over here, right? I don't know how far apart they are. It doesn't matter. So in reference to this first dot, the balloon is to the left. Same thing with the other dot, to the left. I'm going to create a right triangle. I'm going to create a line to both dots. Now it says that it's directly west of the stations, which we did, and the stations are 10 miles apart. So if these are the stations, this is 10 because the stations are 10 apart. It says that the two angles of elevation are 17.6 degrees and 78.2. Well, I know as I'm closer, it's actually a bigger angle because you have to swing your head up higher to look. So the one out farther is actually going to be smaller. I know this is the right angle. So right now I filled in everything that I know. Now I'm going to use x and y. You can use any variables. I'll call this y. I'll call this unknown x. And you could call the hypotenuse right here, you could call it little c. Just make up any variables. Now I like to draw two different triangles when it's inscribed. So I'm first going to do in green this little triangle on the inside. So I drew the green triangle over here. Now I'm going to draw the bigger triangle, and I'll do that in a different color. So if you look at this picture, and we look at the big triangle, big yellow triangle. This angle over here, 17.6 degrees. We'll still call this y, the height of the balloon. Now be careful with this bottom segment. This bottom segment is x, and it's 10, so we have to write x plus 10. It's an expression, so I'm going to throw it in parentheses. When you have two different unknown variables and two different triangles, it's safe to say to set up two different equations. So I'm going to refer to angle 78.2. I'll work on the green triangle first. And I know y is the opposite and x is the adjacent. So SOHCA, TOA. I know TOA, O and A are the x and y. So I'm going to do the tangent of 78.2 degrees. Make sure your modes in degrees is opposite, which is y. Opposite, which is y, over the adjacent, which is x. I'm then going to isolate y. You always just have to isolate any variable, the one that looks easiest. And if I do that, the x's cancel. And if I do that, I get y equals tan 78.2 degrees x, mode degrees. For the yellow triangle, I'm going to do the same thing. So in reference to 17.6 degrees, y is the opposite, and the quantity x plus 10 is the adjacent. So I'm going to write the tangent of 17.6 degrees is equal to the opposite side. The opposite side we're calling y, and the adjacent side is the quantity x plus 10. I'm then going to multiply both sides by the denominator of the quantity x plus 10 so I can isolate y. And when I do that, I get y equals quantity x plus 10 times tangent of 17.6. So now I'm going to distribute tangent 17.6 degrees to the x and to the 10. Remember, tan 17.6 degrees, that's a number, right? This is basic algebra. So when we distribute, we get y equals tan of 17.6 degrees x plus tangent of 17.6 degrees times 10. Now, I'm not plugging this in my calculator right away. I could, and this is a number, and I can multiply by 10, and I get a number. And I could put this in my calculator and get a number x, right? But it's best to round in the very end. You're going to get the best answer. Okay, so then what we do is we do a substitution. So we know if we have y here, if tangent of 78.2x is equal to y, we can substitute in for this y, right? Because you only want to see one variable, then we'll only see x. So we're going to do a substitution. So then after the substitution, you'll notice in this equation you only see x. Now we want to get x's on one side and solve for x. So I can move tan of 17.6x to the left side. So then I would have tan of 78.2 degrees x minus the tangent of 17.6 degrees x is equal to the tangent of 17.6 degrees times 10. You can then factor out an x, and you're left with the tangent of 78.2 degrees minus the tangent of 17.6 degrees is equal to the tangent of 17.6 degrees times 10. And then we're going to just divide both sides by this expression, the tangent of 78.2 degrees minus the tangent of 17.6 degrees. We do that on both sides. And then when we do that, this cancels, so we get x is so it's equal to 0.71. So then if you draw your original triangle, right, and you know that this distance was 10, and you just solved and you got 0.71, and you're still trying to find y, because you need to decide what you're trying to find. It says how high is the balloon. If it said what was the distance from the base of the balloon to the first tower, you'd say 0.71. If it said how far apart were the two towers, you'd say 10. If it said how far from the base of the balloon all the way to the second tower, you would add the bottom two. So you just have to be careful, see what they're asking for. So then if I'm trying to find y, I'm going to say the tangent of this angle, the big blue triangle, is opposite y over adjacent, 10.71. Then we're going to multiply by the 10.71. 71. Make sure your mode's in degrees. Just be careful if it just said, like the angle was 2, your mode would need to be in radians. So then we end up seeing that y is equal to 3.4. Our units is miles. So that's how the balloon is final answer.